This video is made possible by Brilliant. Start achieving your learning goals for 20% off by being one of the first 200 people to sign up at brilliant.org/reallifelore. Once upon a time in YouTube history, MrBeast made a video where he counted all the way from 1 to 100,000. The process took him 40 entire hours to finish, which 100,000. The process took him 40 entire hours to finish, which got me thinking, how far could you actually physically count to if you just kept on going? Like, if you never stopped and just kept on going on and on and on for an infinite amount of time, where would you end up at? The answers to that question start simple, but the numbers eventually get so enormous, so colossal, that the math begins to get really, really weird. Like breaking the universe and reality itself kind of weird. We'll get to that point soon, but let's start out by diving into some number counts that we can actually comprehend first. Once upon a time, 10 years before MrBeast completed his count to 100,000, another bored crazy man had the idea to livestream himself counting not to 100,000, but to 1 million. His name is Jeremy Harper, and in preparation for the task he was setting himself, he requested off from work, locked himself in his apartment room, turned on his camera, and began counting. He would do nothing but count number after number for 16 hours every day, reserving the remaining 8 hours for eating and sleeping. He was determined to never leave his apartment until he reached the mythical number of 1 million, and ordered all of the food that he needed through delivery services. He soldiered on day after day until finally, after 89 straight days of counting one number after another in front of a camera, he finally made it to 1 million and earned the Guinness Book of World Records achievement for the highest number ever manually counted to by a human. So, if you wanted to beat his record and count up to 1,000,001, prepare to spend at least 89 days trying to do it. Now, obviously that is possible to do, but how far could you actually count to if you dedicated all of your time towards it? If counting to 1 million takes around 89 days, and if you kept up that same pace going on from there, and if you began counting from 1 at the age of 10, then by the time you hit the age of 79, which happens to be the average life expectancy in the United States, you would probably end up hitting somewhere around 283 million. And that is if you did nothing else but count day after day for 16 hours every single day. Worst of all, 283 million doesn't even really seem like that huge of a number, especially compared to what's coming next. But in reality, that's probably about as far as a single human being could ever reach counting to during a lifetime. But numbers obviously get way, way bigger than 283 million in the mad world of math. Consider for a moment the difference between 1 million and 1 billion. At first glance, when you're just looking at the numbers, they don't really seem to be that much different. But 1 billion is in fact a vastly larger number than 1 million. If you take both numbers in terms of seconds, you would discover that 1 million seconds is approximately the same as 12 days. That maybe seems like a decently long time until you switch over to 1 billion seconds and discover that's the same as 30 entire years worth of time. And comparing 1 trillion seconds makes even 1 billion look like a puny number, because 1 trillion seconds is almost the same as 30,000 years. 1 million seconds ago was less than 2 weeks ago. 1 billion seconds ago was back when the Soviet Union still existed. And 1 trillion seconds ago, the Neanderthals had only recently gone extinct. Each increase in the order of magnitude from 1 million to 1 billion and 1 trillion dramatically increases the scale of the number that you're talking about. And they just keep getting bigger and bigger after you hit the trillions. You just keep going up through quadrillion, quintillion, septillion, and so on, all the way until you eventually reach a googol, which is the same as 10 to the 100th power, or a 1 with 100 zeros written after it, which, for the record, looks like this. A googol is an absolutely enormous number, and it's almost impossible for our human brains to truly comprehend it. To try and put it into some perspective, 10 to the 80th power is a vastly smaller number than a googol is, but that is already roughly equal to the number of every single individual atom that exists in the entire observable universe. To put it all into even more perspective, consider for a moment the difference in mass between a single simple electron and the entire observable universe with around 2 trillion galaxies. The mass of the electron is 10 to the negative 30th power kilograms, while the mass of the observable universe is 10 to the 60th power kilograms. The difference in mass between the two is only 10 to the 90th power, which is only the same as 0.000000001% of a googol. This means that at the scale of a googol, the mass of an electron and the mass of the entire universe are effectively identical. To blow your mind even more with just how big of a number a googol is, imagine the size of the entire observable universe. It's 93 billion light years across, meaning that it takes light 93 billion entire years just to travel from one side over to the other. It's unbelievably huge, but imagine filling up this entire space from top to bottom and from side to side completely 100% with sand. Imagine being able to fly at the speed of light and flying through nothing but endless sand in every direction for tens of billions of years in whatever direction you choose to fly in. It doesn't matter, it would all seem essentially endless to you. But now imagine counting out every single individual grain of sand in that entire universe filled to the brim with sand. How long do you think that might take you? Eternity is honestly not a far-fetched answer, but after you've finally done it and you've laid to rest the final grain of sand in the entire universe-sized sandbox, you would realize that in order to actually reach a googol grains of sand, you would have to start all over again from grain of sand number 1 and begin counting again from scratch, and repeat that whole entire process over again another 100,000 times. Only then, after you've counted every single grain of sand in the universe-sized sandbox 100,000 times over again, would you finally arrive at a googol grains of sand. But of course, a googol is a puny number when compared with a googolplex, which is simply a googol to the googolth power. It was already basically impossible to imagine how many grains of sand a googol would actually be. So how can you possibly even begin to comprehend the size of a googolplex? Instead of trying to imagine the size of the number, let's just imagine for a moment how long it would actually take to simply write the number out. A typical 400-page book can be written with 10 to the 6th zeros inside of it across every page. So if you just continuously wrote 400-page book after 400-page book with nothing but zeros in all of them, you would need to write 10 to the 94th books in order to reach a googolplex zeros. So to put that into perspective, if each book weighed only 100 grams, there literally isn't enough mass in the entire universe to create that many books, because the mass of all of those books would be heavier than the mass of the entire universe. So if you're just writing out zeros on paper, it's physically impossible to write out a googolplex in full form in our universe, even if you had an infinite amount of time to do it, let alone actually counting to it. The Planck volume is the smallest size that we currently understand in physics. It's such a small space, in fact, that you can fit 100 quintillion Planck volumes inside of just a proton. So if you shrunk your zeros all the way down to the size of the Planck volume, how many zeros do you think you could fit then inside of the observable universe if the entire universe was filled from top to bottom with tiny Planck volume sized zeros? This is the natural limit of numerical expression inside of our universe, the number of the smallest units of measurement that we know of that can fit inside of the biggest thing that we know of. Beyond this, it might be literally impossible to contain any more digits, and the answer is still pathetically small compared with the size of a googolplex. You can only may fit 10 to the 185th Planck volumes inside of the observable universe. To truly appreciate just how gargantuanly colossal a googolplex actually is, try imagining an entire universe beyond our observable universe that's a googolplex meters across in every direction. There are some models of the universe that estimate the true size of the entire universe beyond what we can simply observe to actually be closer in size to this. So if that's true, consider this. Imagine the volume of space that you occupy. The total number of possible quantum states or arrangements of particles that can occur inside of the space that you take up is vastly less than a googolplex. What this implies is that if the actual size of the full universe is actually closer to a googolplex cubic meters in volume, then sheer random probability almost guarantees that there are going to be exact identical copies of you existing somewhere else far away in this same universe. This is because every possible arrangement of matter inside of a human-sized space will likely occur many times inside of a universe this big, meaning that everything that could possibly exist would exist and would exist multiple times, meaning multiple versions of people who are identical to you, meaning multiple versions who are only slightly different than you, meaning multiple versions of every single human you've ever known in your life. Exact copies of every single person you've ever known, heard of, loved, or hated, all throughout history, would still exist somewhere out there far away. If the universe actually is this big, there's almost certainly other versions of you right now doing other things and living their own lives. And some of them might even be doing something a lot more productive than what you're doing now, like learning more about math and science on Brilliant. There are even numbers that are far bigger than a mere googolplex in the realm of mathematics that you can learn all about on Brilliant, like this entire section that explains the number that makes even a googolplex look tiny, called Graham's number. Learning new complex things can often feel difficult, scary, or more than anything, time-consuming. But Brilliant makes it all simple. Take their computer science courses, for example, which start by teaching you how to program a drone by arranging simple instructions. And along the way, you'll learn the basic structure of every program that you'll ever write. Brilliant takes multiple complex subjects just like this and breaks them down into bite-sized chunks so that understanding a new thing doesn't feel impossible. And every course that Brilliant offers has interactive challenges just like this to make learning new things feel interactive and fun. Whether you're totally new to a subject or a professional who's brushing up on cutting-edge topics, Brilliant is the place for you to achieve all of your STEM learning goals. And when you're one of the first 200 people to go to brilliant.org/real-life-lore, or by clicking the link in the description, you can get 20% off of a premium subscription. And as always, thank you for watching.